Welcome back, guys. Today I'll be giving you some concepts related to free body diagrams in physics. Free body diagrams. So, before diving deep into the topic, I'll actually tell you how to draw free body diagrams. While drawing free body diagrams, you need to keep track of two things. The first one is you need to figure out all the forces, figure out all the existing forces. The next one is you need to be sure of its magnitude, be sure of their magnitude and directions. Alright, so let's start with a simple example. So I have an example. For example, I have an object resting on the table. So let's draw a free body diagram for this. So I have this object, it's on the table. So if its weight is given by Fz, then the table actually pushes it upward with some force, which is called normal force. So since it's at rest, you need to be careful about the length of these arrows. So by saying that, what I mean is this should be equal because this object is resting and it's not moving. Alright, so let's go into the second example. I have an object moving forward on the table. So now two cases arise over here. The first one is it moves with some acceleration. So there is net force. So I have a table over here. In which an object is resting. So my Fz will again be balanced by normal force, but this time it has some force that is applied to it, and then since it is moving forward, it also has frictional force that is actually existing between the lower surface of the block and the upper surface of the table. So you have to be very careful about actually figuring out the length of arrows over here, since this object has some acceleration while moving forward. The applied force Fa should have greater length than the frictional force Ff. So next example, if the object moves without acceleration, the existing force will be the same, except this time there will be no net force. So applied force should have exactly same magnitude as frictional force. So Fn will have exactly same magnitude as Fc. So as you can see over here, there is no net force, hence no acceleration. Now let's go into the third example. In third example, we have a hanging mass, hanging on a rope. Alright, so in this case, the force of gravity will be balanced by the force of tension that will act on the rope. Now be sure to check the length of these arrows. They should be equal. Alright, let's go into the problem 4. In this problem, I have a flying aeroplane. So here I have two cases. Case 1, I have an aeroplane ascending up and moving forward. So in this case, let's figure out the forces acting on it. I'll have force of gravity that acts on plane. So since the plane is ascending upward, the force of gravity should be less than the buoyant force, and since the plane is moving forward, the force applied by the engine of the aeroplane should be greater than the frictional force it experiences due to air. Similarly, I can have case 2, in which the aeroplane is flying at constant altitude, or ascending upward with constant acceleration, and moving forward. So in this case, I can have 4 forces. So force applied by the engine of the aeroplane should be greater than the frictional force it experiences, whereas the force of gravity this time will be equal to the buoyant force. So it is because it should not actually experience the net force in vertical direction, since it is either at constant altitude or it's ascending upward with constant acceleration, which means no net force in this vertical direction. So that's how it goes. Alright guys, this sums up the concepts regarding the free body diagram. Please don't forget to like and subscribe my videos. So if you have any further queries regarding these problems, you can just comment on my videos so that I can actually help you out on such regards. Thank you.